Namaskar, hello and a very warm welcome once again to CIET NCERT's live phone and interactive program. So this is a physics class and I am Tanvi Khurana. All the 12th class children, you are here with us and watching us on eVidya channel number 12. आज हम जिस विषय पर बातचीत करने वाले हैं वो है फोटो इलेक्ट्रिक इफेक्ट। फोटो इलेक्ट्रिक इफेक्ट क्या होता है, इससे हम क्या समझते हैं, इसके कुछ एग्जाम्पल्स, हम ये सभी जानकारी पूछेंगे हमारी आज की मेहमान से। अगर आपके पास कोई सवाल है इस चैप्टर से जुड़ा हुआ, इस टॉपिक से जुड़ा हुआ जो आप पूछना चाहते हैं, क्लैरिफाई करना चाहते हैं, तो आप हम तक ज़रूर पहुंचा सकते हैं। आप चाहें तो हमें फ़ोन कीजिए, नंबर है 8800440559। इस वक्त आप हमें लाइव देख रहे हैं हमारे YouTube चैनल पर जो कि है NCERT ऑफिशियल। उसके लाइव चैट बॉक्स में भी आप अपने सवाल लिखकर हम तक पहुंचा सकते हैं। एक स्पेसिफिक ईमेल आईडी भी है हमारे पास जो सिर्फ 12th क्लास के स्टूडेंट्स के लिए है और वो है dth.class12@ciet.nic.in। इस वक्त वो आपकी स्क्रीन्स पर भी फ्लैश कर रहा है, तो इसे प्लीज़ नोट डाउन कर लीजिए और कोई भी सवाल हो तो इस पर ज़रूर हम तक पहुंचाइए। आइए आपका परिचय करवाना चाहेंगे हमारी आज की मेहमान से। वी हैव विद अस मिस ज्योति चौहान मैम। अ वेरी वार्म वेलकम टू यू।
Thank you, ma'am, and namaste to all.
Thank you so much ma'am for being with us today. Ma'am is an assistant professor from Shivaji College, Delhi University. तो चलिए इस बातचीत को शुरू करते हैं और सबसे पहले मैम टाइटल को समझने की कोशिश करते हैं। फोटो इलेक्ट्रिक इफेक्ट, व्हाट डू वी अंडरस्टैंड बाय इट एंड व्हाट इज दिस चैप्टर ऑल अबाउट? क्या फोकस है, क्या हाईलाइट है इस आज के टॉपिक का?
So basically when we say that we are studying photoelectric effect, as the name says, photo comes from photon, light. In physics we consider light to be photons. Photons, they have energy and that energy gets imparted to a metal and through that metal electrons get ejected. So that is why the process is called photoelectric effect. That is, on the projection of photons on a surface, the electrons would get ejected and there would be some flow of current. As you can see in the figure, there is some light which is getting flashed on the surface and some electrons are getting ejected out of the surface. So electrons gets ejected from the metal surface and they contribute to the current, and hence the name photoelectric effect.
Okay, what else it is, ma'am, that we are going to discuss today?
So we will discuss about the theoretical assumptions that in that time scientists had, what photoelectric effect would actually result into, but actually the things that happened were entirely different. Experimentally things were very different. So we will compare the experimental results that were observed and the theoretical assumptions that we had and kind of theories that were used to explain all this effect by various scientists.
So shall we begin?
Yeah, sure.
Okay.
Yeah, thank you. So the photoelectric effect was actually discovered in 1887 by Heinrich Hertz. He was experimenting with electromagnetic waves through spark discharge. Hertz observed that when light shines on a metal surface, some electrons they get ejected, and also he discovered this fact that the radiations that are falling on the surface, they eject electrons with no time lag. So he actually did not took the observations so seriously, but other scientists they really got excited to know this and they studied the phenomenon further. They were so eager to understand this thing, that why all this is happening, how come when some light is falling on the surface without any time lag the electrons are getting ejected out of it. So William Hallwatch and Philip Leonard, they started experimenting it further. They considered the setup that is shown here. Here they had two plates, one is emitter plate and the other is collector plate. The set of plate is connected to some potential difference, and as the potential differences varied, there were various experimental things that were happening. Like as the potential of plate A is increased with respect to the potential of plate C, so what happened is when the light was projecting on plate C, some electrons were getting out of it. And the plate A, it had some potential difference which is lesser than the potential difference of plate C. So the electrons were attracted towards plate A. But what happened when the potential of plate A was increased in negative direction with respect to the potential of plate C, although electrons being negatively charged, some of the electrons could still reach plate A, some electrons could not reach plate A because of the negative polarity of plate A. So, as the potential was further increased, the ejected electrons could not reach plate A because they were getting repelled by plate A, and the electrons did not have enough or sufficient kinetic energy to reach plate A. So, this was noticed. They further studied the variation of photocurrent with respect to the intensity of the light. What happened? What is photocurrent? Photocurrent is actually when the light is falling on the surface, the electrons are getting ejected. Whenever we talk about the motion of the electrons, motion of the electron means that there is some current. So, because these electrons are getting ejected because of the photons that are falling on the surface, hence the name photocurrent. So, photoelectric current was increasing with respect to the intensity of the light. It says that as you keep on increasing the intensity of the light, that is the overall energy that you are projecting on the surface, the number of photons that are emerging out of the surface should increase, that is the photoelectric current should increase. This was noticed, and this happened when the frequency and the potential that was applied to the set of plates was kept constant. Another observation was that as for every material there is certain minimum frequency that light should have, so that as this minimum value of frequency is crossed, the sufficient energy is acquired by sufficient energy is delivered to the electrons of the plate, so that they can get out of the surface of the plate and contribute to photoelectric current. As this figure is shown here, we can see that we have three curves. One curve has some retarding potential minus VO3, another is minus VO2, and the third one is minus VO1. Retarding potential is basically the negative amount of potential that you supply to plate A as shown here in this diagram, so that the electrons that are having even the maximum of the kinetic energy, they can be stopped. So, this is what the retarding potential is. But what happens is that as you keep on increasing this negative potential, the electrons would stop reaching plate A, because of which there is no current at the end. So, this saturation current is basically when all the electrons are ejected out of the surface, the maximum current that can be there, because it's not happening that you are supplying sufficient amount of energy and after that if you keep on increasing the energy, so we should have extra electrons to get ejected out of the surface. But here it is not happening. You have a limited amount of electrons that can get ejected out of the surface, so that is why you get this saturation current. Now, this is another experimental observation. It says that the photoelectric current is 0 when the stopping potential is sufficient to repel the most energetic photoelectrons. That is, the maximum kinetic energy should be equals to eV0, where V0 is the sufficient stopping potential that is applied to stop the electrons from reaching the plate A. Then this graph is really important. It has two conclusions here. One conclusion is that stopping potential varies linearly with the frequency of the incident radiation for a given photosensitive material. Photosensitive materials are those which are sensitive to the light that is projected on them. And the second observation was that there is certain minimum cutoff frequency for which the stopping potential is 0. That is, it's not that for every cutoff frequency you can get the current. So, there is certain minimum frequency that is there. Now, in photoelectric effect there were many things which were noticed, like we noticed that not for every frequency the electrons would eject out of the surface, and also there is some stopping potential for every material, and also we noticed that as the intensity increases, photoelectrons the number of photoelectrons increases because of which the photoelectric current has a linear relationship with the photoelectric, as we shown here, the photoelectric current has a linear relationship with the intensity of the light. But these were the things that were observed through the experiment, but there were certain things that were observed through the experiment but could not be explained through the existing theories. Like if we see the classical predictions said that the maximum kinetic energy should increase with intensity, that as the intensity of light that is falling on the surface increases, the maximum kinetic energy of the electron should increase. This is what classical prediction is, but experimentally this was not noticed. Experimentally we noticed that the maximum kinetic energy of the electron is independent of the intensity. Second classical prediction was that light with same amplitude should impart same energy to the electron. This means that even if you fall red light, yellow light, UV light, they should always provide the same energy to the electron that is there on the surface. But what happened is, this is not the scene. Not every light would imparting the same amount of energy to the surface electrons, because later on it was found that the energy that is getting imparted to the surface, it depends upon the frequency of the light that we are using. So as the next point says, that frequency of light should have no impact on maximum kinetic energy. This was the classical prediction, but experimentally it was noticed that the frequency of light, or we can say wavelength of light, because frequency is nothing but the speed of light divided by wavelength. So both wavelength and frequency should have some impact. Also classically it was thought that if you project some dim light on the surface that is having a lesser intensity, it should eject electrons from the surface of the metal, but the electrons should get ejected after some delay, some time delay. But experimental observations were entirely different. Experimental observations said that as you project some light, and if that light is having the minimum energy that is needed to take out the electrons out of the surface, then the electrons should immediately come out of the surface with no time lag. But theoretical observations or classical predictions were entirely different. Also experimentally we noticed that high frequency implies higher kinetic energy to the liberated electrons. Like what electrons which are getting out of the surface, they will be having higher kinetic energy, they will come out of the surface with more energy as compared to the electrons which are supplied with lower frequency values. So there were many contradictions between the theoretical assumptions, classical discussions and the experimentally observed results. So one of the finest explanation that was given by Einstein on photoelectric effect, for which Einstein was awarded Nobel Prize as well in 1905. He understood the very important thing that he understood was that light follows particle nature here. It is not a wave nature, it is particle nature. So what do we mean by particle nature? That we say that light is quantized. When we say light is quantized, this means that as light is falling on the surface, the photons are actually falling on the surface. And what are photons? Photons are nothing but they are small packets of energy having value h nu, where h is the Planck's constant and nu is the frequency of light. So the equation that is shown here on the screen, it is kmax is equals to h nu minus phi naught. What is kmax? Kmax is the energy of the electron, maximum kinetic energy of the electron that is getting ejected out of the surface, and h nu is the energy of the incident radiation. If some radiation having frequency nu is falling on the surface, so it will be having h nu energy, but not all the energy is directly getting supplied to the electrons. What happens is that there is a term which is called as work function, which we have written here phi naught, or later it is replaced as h nu naught. So in experimental results we just studied that every material has some fixed minimum value of frequency for which the electron should eject out of the surface. So that is called as the work function of the surface. So work function of the surface is unique for a particular surface. Like in the next graph we will see. Let me take you to that, we will come back.
Okay, ma'am, I have a question to ask here, may I?
Yes, sure, ma'am.
So, can an electron take energy from two photons and then eject out if the energy of one electron is not sufficient?
No, actually what happens is here we consider that only one photon would impart energy to one electron only. Or we can also say that only one electron would take energy from one photon. It's not that one electron would wait that okay, let me take energy from this photon and then I'll take energy from the next photon and then I'll eject out of the surface. This doesn't happen.
Okay. Can you define intensity of incoming radiation for all our viewers?
Yeah. When we say that in intensity of a light, we are actually talking about the number of photons that are falling on a unit area surface in 1 second. So this is what intensity is. Higher is the intensity, means higher is the number of photons that are falling on the surface.
Okay, all right.
So here what's happening is, if you see this graph, if you see this diagram, here what's happening is we have a metal surface. This metal surface is made up of atoms, and atoms has electrons. So when energy of h nu naught magnitude or nu naught frequency is falling on the surface, so some electrons, this energy is getting imparted to the electrons on the surface. So they'll come out of the surface with almost zero kinetic energy. This means that they'll come to the surface and be rested there. But on the other side, if you see that if energy is having some magnitude h nu and this frequency nu is greater than the minimum frequency that is required to take electrons out of the surface, then the maximum kinetic energy with which an electron can come out can be given as h nu minus h nu naught, where this h nu naught is the work function of the surface. If I take a different surface, this nu naught frequency would change as the electrons or the atoms are bound to the surface in a different manner. So every surface would have a different work function. So this equation we were talking about, this is your Einstein's photoelectric equation. This says a lot about the experimental observations that we had. Einstein hypothesis had major 3 points. One hypothesis was that electromagnetic wave is actually nothing but a collection of photons. So as the photons fall on the surface of the metal, either the electron would eject out of the material or it would not eject out of the material. As so far we had wave theory. When we consider wave theory, in wave theory what happens is that energy is getting imparted to the metal surface like wave fronts. So होना क्या चाहिए था कि वेव फ्रंट्स जब कॉन्टिन्यूसली एनर्जी सरफेस को प्रोवाइड कर रहे हैं, तो होना ये चाहिए था कि एक इलेक्ट्रॉन ने एनर्जी ली, देन कॉन्टिन्यूसली वेव फ्रंट्स जो हैं वो ट्रैवल कर रहे हैं एंड उस इलेक्ट्रॉन तक पहुंच रहे हैं, तो थोड़े टाइम बाद इलेक्ट्रॉन को उतनी सफिशिएंट एनर्जी मिल जानी चाहिए थी जितनी ज़रूरी है उस मेटल सरफेस से बाहर निकलने के लिए. बट दिस वॉज theoretical assumptions as per the wave theory, but this was not what we observed experimentally. Experimentally it was noticed that with no time lag the electron should come out of the material. Either the electron would immediately come out or it would not come out. So here the wave theory was wrong and particle theory actually corrected that thing. Then the next hypothesis was all photons of the same frequency have same energy. So changing intensity of light will change the number of photoelectrons but not their energies. So suppose if we have some photon which has energy h nu, but that energy is not sufficient to take the electrons out of the material, then even if you keep on falling light of that particular magnitude for say 1 year or 2 years, that won't eject the electrons out of the material, because for a particular material we have a minimum threshold frequency that the incoming light should have to take the electron out of it. So which is called as work function, as we studied. And the third is, higher is the frequency of the light, the greater the photon energy and hence more energy of the photoelectron. The frequency of light should be higher. जितनी ज़्यादा इनकमिंग रेडिएशन की जो फ्रीक्वेंसी है वो हाई होगी, मतलब कि उतनी उसकी एनर्जी ज़्यादा है. तो as we could see here, kinetic energy, which is maximum kinetic energy, is nothing but h nu minus h nu naught. H nu naught is fixed for a particular material. So as you increase the nu, that is the frequency of the incoming radiation is high, so kinetic energy, which is maximum kinetic energy with which the electron would get ejected out of the surface, should be higher. This is what also Einstein said in his third hypothesis. After going through this particle theory which Einstein gave, and when the experimental results that we could previously get were again gone through, these were the observations, the corrected observations, the corrected explanations that we had. Maximum kinetic energy of the electron, this depends linearly on the frequency of the radiation, and it is independent of the intensity of the radiation. As we learnt just now, that intensity is nothing but the number of photons that are there per unit area per second. So if you keep on increasing the number of photons, it doesn't imply that those photons are capable of taking electrons out of the surface. So this increasing intensity may not, increasing intensity would not increase the maximum kinetic energy that the electron should have. So in Einstein picture, photoelectric effect arises from the absorption of a single quantum of radiation, or we can say a single photon by a single electron. Then the second observation was photoelectric effect or photoelectric emission is possible when h nu is greater than the work function. This is what we learned just now, that every material should have some minimum, it is the energy with which the electrons are bound to the surface. So you need to overcome this energy which is binding the electrons to the surface. So h nu, the incoming radiation की जो energy है, that should be greater than the work function for photoelectric emission to take place. And this frequency is called the threshold frequency, and it is given as work function divided by Planck's constant. So these are few definitions, like what work function is. It is the minimum energy of one photon required to take out the electron. Then ejection of electron depends upon the energy of the photon. It does not depend upon the intensity but the energy, that is the frequency of the incoming radiation. As you can see, I have explicitly written that it doesn't depend upon the total energy, that is intensity. That is a point to be noticed here. It's like if you have one bulb which is giving some amount of energy, if you have 1000 of such bulbs having the same energy, you cannot take the electron out of the material until or unless the bulb is having the energy which is greater than the work function. And work function, threshold wavelength and threshold frequency, they all depends upon the surface of the metal, the kind of metal that you have. So we just heard that wave nature, particle nature, Einstein could explain all the results using particle nature. So what would have happened अगर हम wave nature ही consider करते? तो as I said one thing, अगर हम wave nature consider करते तो continuous energy supply हो रही है. Continuous energy is getting supplied through wave fronts to the metal surface. The electrons available there. So maybe after 1 hour or 2 hour कोई एक electron ऐसा होता जो sufficient energy gain कर लेता and eject हो जाता. But this was not actually happening. So wave theory failed here, and particle theory could explain it that the entire photon would impart energy to the electron, and if that energy is sufficient to take the electron out of it, so electron would emit, otherwise it won't emit. Then photoelectric effect supports particle nature. This is clear from here, but not wave nature. And what would have happened is that for low intensity, the electron would have ejected with more delay. If the intensity is low and you are keep on supplying that light with the same intensity for a longer duration, so the electron would have come out if we have trusted on wave theory. But this was not happening. There was no time delay. Actually, the electrons were instantaneously coming out of the surface as the photons were falling. So this was explained through particle theory only, not wave theory. वेव थियरी पे अगर हम भरोसा करें तो उसके हिसाब से अगर आप ज़्यादा देर तक एक पर्टिकुलर इंटेंसिटी की लाइट को इंटरैक्ट कराते हो इलेक्ट्रॉन से, तो द इलेक्ट्रॉन शुड कम आउट, बट दिस एक्चुअली डजंट हैपन. And one more point is that emission of electrons should not depend on wavelength and frequency. This is what wave nature says, because we just learned that कि अगर आप intensity continuously provide कर रहे हो, so electron should eject out. So it means that frequency or wavelength has no role to play, but that was not happening. As the frequency was changed, the behavior changed. For some materials at certain frequency the electron emission was happening, and for other materials at that frequency electron emission was not happening. Yeah. So wave nature implies that electron emission should take some time, but photoelectric effect is an instantaneous effect as light comes as photons, and this was experimentally verified through particle theory. Yeah. Now we have learnt two things so far. One thing is that whether electron would come out or not. We learnt about work function, that there should be some minimum energy, there should be some minimum frequency which is called as threshold frequency, and that should be followed, that should be imparted the surface with, so that electrons can come out. This is one thing, that कि electron बाहर आएगा या नहीं आएगा. Then the other thing is कि electrons अगर बाहर आएंगे तो कितने electrons बाहर आएंगे. तो number of photoelectrons actually depend upon intensity, because intensity is what? Intensity is nothing but the number of photons that you are supplying, that you are projecting on the surface per unit area per second. तो कितने number of photoelectrons आएंगे, that depends upon the intensity, but not the fact that whether the electron would come out or not. Even if with a very high intensity, the electron may not come out, and this is the role of the work function. Okay. So not every photon would be able to take out the electrons, as the electrons on the surface may get out on striking. क्यों ऐसा नहीं होगा? एक तो हमारा ऐसा होता है कि इलेक्ट्रॉन जो है, इलेक्ट्रॉन बाहर आएगा या नहीं आएगा, फिर कितने इलेक्ट्रॉन्स बाहर आएंगे, दैट डिपेंड्स अपॉन इंटेंसिटी. एंड देन द थर्ड थिंग इज that if you are supplying sufficient amount of energy to the metal surface, so क्या ये ensure करता है कि electrons बाहर आएंगे या नहीं आएंगे? That is another thing. What happens is, even if you are supplying your metal with sufficient energy that is greater than the work function, then also the electrons may not come out. ऐसा क्यों होता है? क्योंकि जब आप एनर्जी सप्लाई कर रहे हो एक मेटल को, तो सरफेस पे जो इलेक्ट्रॉन्स, सरफेस पे जो एटम्स हैं, उनके जो इलेक्ट्रॉन्स हैं, वो तो इमीडिएटली बाहर आ जाएंगे, बिकॉज देयर इज़ नथिंग विच इज़ हिंडरिंग देयर, और देयर इज़ नथिंग विच इज़ स्टॉपिंग देम टू कम आउट ऑफ द सर्फेस. सो दे विल कम विद अ गुड अमाउंट ऑफ एनर्जी एंड दे विल कम readily. But what happens is, as light falls on the surface, so surface के नीचे भी हमारे पास atoms हैं, वहाँ पे भी electrons available हैं. So those electrons which are under the surface, they'll gain some energy, and as they'll try to reach the surface, on reaching the surface, they will be losing some energy in this process. It's like if I ask a student to come out of the class, and that particular student is sitting close to the door, so that student would be very comfortable and can exit the classroom with a very high speed. But if I ask a student who is sitting at the very end of the class and the class is highly full, so that student would have to struggle in exiting from the classroom. So that student would try to गेट अप फ्रॉम द सीट, एंड वो अपने बाकी फ्रेंड्स को हटाएगा, देन वहाँ से आएगा, तो उसमें उसकी बहुत एनर्जी चली जाएगी. तो मे बी स्टूडेंट जो है वो नहीं ही निकले बाहर, हो सकता है वो वहीं रुक जाए क्लास के बिगनिंग में, या फिर हो भी सकता है कि वो एग्जिट कर जाए. अगर बहुत हाइपर एक्टिव कोई है तो दैट स्टूडेंट में एग्जिट. सो दिस इज व्हाट इज हैपनिंग विद द इलेक्ट्रॉन्स एज वेल. जब आपने इलेक्ट्रॉन को एनर्जी सप्लाई की, सरफेस के नीचे जो इलेक्ट्रॉन्स है, दे विल गेन द एनर्जी, बट दे may not come out of the surface. They will gain the energy, they will struggle to come out. उनका बाकी जो atoms हैं, बाकी electrons हैं, उनसे repulsion, atom से collision, वो सब होगा, and then उसके बाद वो surface पे आएंगे. तो surface पे आते टाइम हो सकता है उनके पास उतनी energy बचे ही नहीं जितनी उनको चाहिए थी बाहर निकलने के लिए. तो and actually in real life this happens. It's not that you are supplying with 1000 photons, 1000 electrons would gain the energy of the 1000 photons and they'll come out, even if this energy of individual photon is greater than the work function. So what happens is, when you supply 1000, 2000, 5000 photons, then one electron is capable of getting out of the surface because of the collisions amongst the other electrons and the atoms and the repulsive forces that are there. So one electron would take energy from one photon electron, and one photon would supply energy to one electron only. So these are two different things. One is that not every electron is capable of getting out of the surface, as the, even if the energy is greater than the work function. This is one thing. Another thing is that maybe the electron would wait ki let the other photon come, I will gain the energy and get out of it. No, this doesn't happen. One electron can take energy from one photon only, either it is properly utilized or not utilized. This is what happens. So even with, so here I would like to conclude this, that even with sufficient energy, electrons may or may not come out of the metal surface.
Okay, ma'am, I have a doubt here. So, is it possible that every time electrons would come out if the frequency of the incident light is greater than the threshold frequency?
No, it's not possible every time, because even if the frequency of the incident light is greater than the threshold frequency, the ejecting electrons, which is not on the surface, which is under the surface, may undergo various collisions with other atoms and other electrons. So this will degrade the energy acquired by the electron, and while reaching the surface, the electron may left with the sufficient amount of energy that is required to escape the surface.
Okay, all right. And I want to ask one more question. So if we add too many sources with the high intensity, can we then make an electron eject out of the surface?
No, actually what happens is that too many intensity means that you are just supplying with a greater number of photons.
Right.
But if a particular photon is already not having sufficient amount of energy that is needed to take electrons out of the surface, so even if you provide 1000 such sources of energy, that would not be able to take the electron out of the surface, because the amount of energy that is needed for an electron to get out of the surface is actually work function. Work function is specific to a particular material, and that material is the atoms and the electrons are bound to that material. So that particular amount of energy you should supply so that an electron can get out of the surface.
Okay, all right, thank you.
Yeah. So even if the energy is higher than the work function, still the electron may not come out. This is what we have discussed here. So as you can see the expression which is here on the screen, there is this circuit that I showed in the very beginning. This is the circuit on the right side. Here what happens is that we have a source of light. That source of light is actually shining on the plate C. So the electrons that are available on this metal plate C would eject out of the plate, and they will start moving towards plate A, and this is contributing towards some current in the circuit. So what happens here is that the amount of energy that you are supplying to the plate is intensity, that is the total energy, that is intensity. So if I divide, how do you calculate the intensity? Intensity is the number of photons divided by the time for which you are bombarding those photons on the plates, and you multiply it with the energy of one photon. So energy of one photon is h nu, or you can also say it is hc by lambda, where lambda is the wavelength of the incoming radiation, or frequency is the or h nu, where nu is the frequency of the incoming radiation. So frequency and wavelength, they have inverse relation. As frequency increases, wavelength decreases, or as frequency decreases, wavelength increases. So here what I am saying is that if I make this light which is coming from the source S to fall on the plate C, electrons are getting ejected and it is contributing towards the current that is flowing through the circuit. So if I wish to know that how many photons are falling on this plate, so what I can do is I can know the intensity of the source and I can divide it by the energy of a single photon. So how do you calculate energy of a single photon? It is hc by lambda. We know the wavelength that we are wavelength of the light that we are shining on the surface. So if we know the value of hc by lambda, we can divide it by the total intensity. That will give me the number of photons that are falling on this plate. This is one thing. And if I wish to know this is what I have written here, I divided by hc by lambda. This is giving me the number of photons that are falling on the surface. And on this, in this equation on the left side, you can see there is small I divided by E. This small I is basically the current that is getting created in the circuit due to the ejection of electrons from the metal surface. So this current, if I divide it by the charge of an electron, because current is nothing but it is the flow of electrons per second. So it is dq by dt. So if I divide the charge of the electron, if I divide the current by the charge of the electron, this will give me the number of electrons that are there. So when we say that even if 1000 or 2000 photons fall on the surface, only it is capable of taking one photon or maybe 2 photons out of the surface. So what's happening here is that this equation is showing an inequality, that I by E, which is giving me the number of electrons that are getting out of the metal surface, is not equals to the number of photons that are falling on the surface. So if this equation becomes equal, then we say that the number of electrons, the number of photons that actually had fallen on the surface, they are equally getting absorbed by the equal number of electrons, and those electrons got ejected out of the surface. Now, so there are two things that are to be explained through this graph. What happens is that we say in photoelectric effect, a very big conclusion that we have, this is that the intensity dependency of the photoelectrons, the energy with which the photoelectrons would come out or whether they would come out or not, is not there. इलेक्ट्रॉन बाहर निकलेगा नहीं निकलेगा या फिर कितनी एनर्जी के साथ निकलेगा, इसकी डिपेंडेंसी आपकी फ्रीक्वेंसी और वेवलेंथ पे है, इसकी डिपेंडेंसी इंटेंसिटी पे नहीं है. दिस इज़ वन थिंग. So as the frequency increases, the energy with which the electrons gets out of the surface, that also increases. This is one thing. And also, if this energy that is falling on the metal surface is lesser than the work function, this means that your light that you are projecting on the surface is not capable enough to take electrons out of it. So either you increase the frequency of the light for that particular material, or you decrease the wavelength so that it acquires the sufficient amount of energy that is needed for the electron to come out of the surface. So there in this plot, here you can see it is for metal A and metal B, and we can notice that the plot of the metal A is not starting from 0. It is actually starting from a point where you can see nu naught is written, and for metal B the point nu naught prime is written. So what's happening here is nu naught is actually the threshold frequency. जैसे वर्क फंक्शन h nu naught होता है, तो उस वर्क फंक्शन को अचीव करने के लिए यू नीड अ थ्रेशोल्ड फ्रीक्वेंसी वैल्यू दैट योर लाइट दैट यू आर सप्लाइंग योर metal with, it should have. So this nu naught is the threshold frequency of metal A, and nu naught prime is the threshold frequency of metal B. So for metal A, if I talk specifically about metal A, here we are continuously increasing. Here what we are saying is we are supplying the metal with certain frequency energy, and that is not sufficient to take out the electron out of it. Then we have increased the frequency, still the electron is not getting out of it. Then we further increased it, and the moment we reached this nu naught value, this could impart the minimum, the very minimum amount of energy that is needed to electron to get out of the surface. And as you increase the frequency further, so now the minimum condition we have achieved. So as you increase the frequency further, you can say the graph goes high. So this is the same thing is followed for metal B. Metal B has a work function which is greater than that of the metal A, and hence the graph which is actually rising, the stopping potential is showing a linear relationship with the frequency of incident radiation. So this graph is starting for a frequency value which is greater than the work function or the threshold frequency of metal A. So before this threshold frequency, no ejection was noticed experimentally, and also this was explained through Einstein's hypothesis. He said, as you project some energy on the metal surface, So that energy should be, that quantum of energy, that photon should have sufficient energy to immediately supply it to the electron, and the electron takes it with no time lag and it gets out of the surface. So either ejection होगा या फिर नहीं होगा. अगर होगा तो एक ही कंडीशन के अंडर होगा कि फ्रीक्वेंसी जो है वो उतनी होनी चाहिए जितनी वर्क फंक्शन को ओवरकम करने के लिए ज़रूरी है. इफ़ यू सी दिस इक्वेशन, not this one, yeah, if you see this equation, if this work function is exactly equals to the if the incident energy is exactly equals to the work function, that is if I make nu is equals to nu naught here, so we can say k max is equals to 0. This means that electron would come out of the surface because it has this minimum energy, but it will remain on the surface. It would not travel apart from the surface. As you increase the frequency value, this maximum kinetic energy increases. And in this previous graph, we were plotting the stopping potential. Why stopping potential increases with frequency? Because stopping potential is that potential that you need to apply on the set of plates that we considered to stop the electron which is having even maximum of the kinetic energy to reach to the other plate. So that is what a stopping potential is. In this experimental results, let us talk about these experimental results. First result says that Kmax is independent of light intensity. This we have studied. Why Kmax is independent of light intensity? Because कितनी एनर्जी के साथ इलेक्ट्रॉन निकलेगा that is depending upon the wavelength or the frequency only. इंटेंसिटी पे सिर्फ कितने फोटोन्स निकलेंगे वो डिपेंड करता है. इफ़ यू कीप ऑन शाइनिंग अ लाइट हैविंग सर्टेन इंटेंसिटी, तो उससे नंबर ऑफ फोटोन्स कितने निकलेंगे वो डिपेंड कर रहा है. It is not judging whether it is not telling you anything कि इलेक्ट्रॉन बाहर आएगा या नहीं आएगा. That depends upon frequency or wavelength. Next is higher frequency implies higher kinetic energy of liberated electrons. Yes, we noticed this thing. As the frequency increases, kinetic energy, maximum kinetic energy of the electron increases, and hence the stopping potential also increases. Then the next is light below a certain value liberates no electrons, irrespective of the intensity of the potential value. Yes, this talks about the potential, the work function. वर्क फंक्शन की जितनी वैल्यू होती है फ्रीक्वेंसी की, विच इज़ थ्रेशोल्ड फ्रीक्वेंसी, उतना अचीव करना पड़ेगा, उससे ऊपर फ्रीक्वेंसी वैल्यू सप्लाई करनी पड़ेगी सो दैट इलेक्ट्रॉन्स बाहर निकल सके, अदरवाइज इलेक्ट्रॉन्स बाहर नहीं निकलेंगे. एंड दीज इलेक्ट्रॉन्स विच आर कमिंग आउट, दे आर कमिंग आउट विद नो टाइम लैग. इट इज़ एन इंस्टेंटेनियस प्रोसेस. अगर हम वेव थियोरी देखते हैं तो वेव थियोरी के अकॉर्डिंग ये प्रोसेस इंस्टेंटेनियस नहीं होगा. अगर आप डिम लाइट भी सप्लाई कर रहे हो तो धीरे धीरे क्या होगा, आफ्टर से 1 hour और 2 hour the photon would be able, the electron would be able to gain the sufficient amount of energy that is needed so that it can get out of the surface. तो वहाँ पे टाइम लैग होगा, but experimentally this was not noticed. So these are the classical predictions that Einstein could overcome through his particle nature of the light. So we have read this thing which is called wave particle duality. What is wave particle duality? Wave particle duality says that the particles that we have, they have both the nature, particle nature and wave nature. Like if you talk about the interference of light, diffraction of light, so that is basically the wave nature of light. If it is a particle nature, then you would not get interference of light, you will get the dots on the surface. But here this particle nature is highly useful in explaining the photoelectric effect. Ma'am, it's not working. So this is wave or particle nature. Okay, so we could not have considered classically earlier to this wave nature was known. That is why many scientists, they had experimental observations. They could notice that yes, there is no time lag. They could notice that frequency and wavelength dependent चीज़ें हो रही हैं. They could notice that intensity had no role to play in the ejection of electrons. It just increased the number of electrons if they are getting ejected out of it. But these things could not be explained through wave nature. So Einstein got a Nobel Prize in this because he actually he had put forward this theory of particle nature for explaining the photoelectric effect, and all the experimental results that we gained, they could be explained using this particle theory. I can talk more. Yeah? The slide is not. Okay, so in Einstein hypothesis, what happened is that electromagnetic radiation waves were considered to be photons. What are electromagnetic waves? Electromagnetic waves are basically combinations of electric field and magnetic field. So Einstein considered that these electromagnetic waves are available as a packet of energy, that is photons. One photon has energy h nu. H nu is Planck's constant and nu is the frequency. जितने भी फोटोन्स हमारे पास होंगे, अगर उन सब की सेम फ्रीक्वेंसी है तो उन सब की सेम एनर्जी होगी. तो इसका मतलब कि ऑन चेंजिंग द इंटेंसिटी ऑफ लाइट, this will change the number of photons only but not their energies, and hence the surface of the metal was to be supplied with some other frequency value so that it could take the electrons out of the surface. If you do not change the frequency, you keep on shining the same amount of energy for longer duration. This did not help the electrons in overcoming the boundation that it had with the surface, and the electrons could not come out. This graph is very important. This graph is showing the variation of photocurrent with the potential that is supplied to the plates. So what's happening here is, if we see the variation of the graph, it is starting with some V0 value, minus V0 value, which is the stopping potential, or it gives you an indication of the maximum kinetic energy that an electron has. So as you keep on increasing the anode potential, what's happening here is, after certain time you see I2, I3 and I1 value, they are becoming constant. Even if the anode potential is getting increased, this is not increasing any further. Why is this happening? Because for a particular metal, there are fixed amount of electrons that can get liberated out of the surface. So after one particular point, maybe all the electrons that could get out of the surface वो बाहर आ चुके होंगे. तो उसके बाद क्या होगा कि ये जो करंट की जो वैल्यू है, ये आपकी सैचुरेट कर जाएगी, क्योंकि करंट इज नथिंग बट फ्लो ऑफ इलेक्ट्रॉन्स. अगर करंट बढ़ाना है तो यू नीड टू प्रोवाइड मोर नंबर ऑफ इलेक्ट्रॉन्स. सो जब हम फोटो करंट जनरेट कर रहे हैं, जब इलेक्ट्रॉन्स सरफेस से बाहर आ रहे हैं, तो एक टाइम के बाद वो सरफेस से बाहर नहीं आना बंद कर देंगे, क्योंकि जितने सफिशिएंट एनर्जी उनको चाहिए थी निकलने के लिए, जितने इलेक्ट्रॉन्स निकल सकते थे बाहर, वो निकल के आ चुके हैं. तो करंट अब फिक्स हो चुका है. तो इट इज़ अ सैचुरेशन. I1, I2 and I3 इज शोइंग सैचुरेशन एट द एंड, that there is no increment in the photocurrent after a certain value of the potential, because applying higher potential doesn't mean that even if the metal has reached its maximum capacity of free electrons, it will keep on supply. It cannot supply beyond a certain capacity. So that is why we are getting this saturation here. And here this is showing the variation of photocurrent with the collector plate potential. So all the plates they are having it is showing this nu3, nu2 and nu1, these are the frequencies. It is showing the variation of photocurrent with respect to the frequency. For higher frequency, as we know, higher frequency means what? That the electrons would get out of the surface with higher energy. Higher kinetic energy means what? That the stopping potential or the retarding potential should be high. So if we see nu3 frequency, it has the highest value out of all the three frequencies which are here. So this V3 retarding potential jo hai, it will have the highest value, because of nu3 the electrons that are getting ejected out, they will be having higher kinetic energy. and nu2 is having value higher than nu1 but lesser than nu2, hence the stopping potential for nu2 is lying between the stopping potential of nu3 and nu1 values. And again the photoelectric current is getting saturated because of the same reason, because after certain point the photoelectrons, the maximum number of electrons that can come out of the surface would have come out. There would be later on no extra electron in the surface that can now come out after taking a certain amount of energy. So minimum negative or the minimum negative potential or the retarding potential or the stopping potential is given to plate A, for which photocurrent stops or becomes 0. This is called the cutoff stopping potential. This is the diagram. Here we are talking about this plate C and plate A. The potential that is getting varied here is actually the potential difference between the plate C and plate A. What actually potential difference is? When we say there is a potential difference, it means that you are creating a difference that is needed for the current to flow. We all know about Ohm's law. So Ohm's law says that current is directly proportional to the potential difference. जब तक पोटेंशियल डिफरेंस क्रिएट नहीं होगा करंट फ्लो नहीं कर सकता. अगर दो पॉइंट पे पोटेंशियल सेम है तो इसका मतलब कि उनके बीच वो ग्रेडियंट नहीं है जो करंट को फ्लो कराने के लिए, इलेक्ट्रॉन्स को मूव कराने के लिए चाहिए. इट्स लाइक यू हैव टू कीप सम वाटर एट सम हाइट सो दैट वो नीचे जो एक कंटेनर रखा है उसमें अपने आप फ्लो करके आ सके. सो देयर इज दिस ग्रेडियंट. इसी तरीके से अगर दो प्लेट्स के बीच आपको इलेक्ट्रॉन्स को फ्लो कराना है तो यू नीड टू प्रोवाइड वन प्लेट विद अ हायर पोटेंशियल देन द अदर, एंड दिस ग्रेडियंट वुड हेल्प in traveling of electrons, and the electric field gets created here. So as you keep on increasing the potential of plate A in the negative direction, so what happens is from plate C electrons are getting ejected out, and these electrons themselves being negative are getting repelled from the negative potential of plate A. So you need to keep on increasing the negative potential of plate A so that you can completely stop the electrons from reaching plate A, and this potential is basically we are calling as a stopping potential. The potential, maximum potential that is needed to stop the electrons that are having maximum of the kinetic energy is given by this equation.
Okay, ma'am, we don't have much time left, so I would request you to please wrap up.
Yeah, sure. Thank you. Thank you.
Thank you. Thank you so much, ma'am, for explaining the concept of photoelectric effect to all our viewers, to all our children, and you have clarified all the questions.
Sure.
And thank you so much for being with us today. It was wonderful having you.
Same here.
Thank
I had
you.
a great experience.
Thank you to all the children as well for being with us today, and I really hope that you enjoyed this particular program. If in case you want to understand more about photoelectric effect, please raise your questions and share them with us. Feel free to share them. And so far we are wrapping up this particular program, and we are also wrapping up all our programs for today. But we'll come back on Monday once again with more topics, with more subjects, and you can watch us on eVidya channels and also on our YouTube channel, that is NCERT Official. So this was our physics class for all the children who are studying in class 12th. This was an important topic to discuss, photoelectric effect. I really hope that if in case you have missed this program, please watch it again on NCERT Official, that is our YouTube channel. Anytime, where you are, you can watch it. All you need is an internet connection. So thank you so much once again, and before leaving, just want to remind you once again that NCERT textbooks for this new academic session, that is 2023-2024, they are available throughout the country now, and you can simply purchase these textbooks from directly the sales counter. The sales counter are located in New Delhi, Bangalore, Kolkata, and Guwahati. So the timings are 9:30 to 6 p.m. and if in case you just want to place an order with the help of the website would be ncertbooks.ncert.gov.in. Place an order and sit at your own place, and the books will be delivered at your doorstep with no delivery charge at all. If in case you are planning to go for the soft copy or the PDF version, just simply download the PDF version with the help of NCERT Diksha or ePathshala's website or their mobile applications. So this is all the information regarding NCERT textbooks, and I really hope that you're going to buy these textbooks and read them all very, very soon. Thank you so much once again. Have a great day ahead. I'm Tanvi Khurana and I'll take a leave of you. Namaskar.